Hello, all. Hope you're doing well. Hope your semester is going good so far. We only have few more days left, and we almost made it. So this question was asked by by a student. As you can see on my screen, there is a polynomial with degree 4. Highest power of x is 4, and one of the zeros is given as 7i, which is a complex zero, and we have to find the remaining zeros. So usually when we have these kind of questions, if we have a cubic polynomial, one zero is given, and then we perform synthetic division, we find the quotient, which is the quadratic, and then factor that quadratic polynomial or the quadratic equation using quadratic formula or factoring. Now this is not a cubic function, this is a fourth degree function. Degree means highest power of x. So whenever a fourth degree polynomial is given, we are usually given two zeros because we have to perform synthetic division twice. But in this case, only one zero is given, which is 7i. Now, there is a beautiful theorem which is written in the blue right here on the screen, that if there is a polynomial with real coefficients and one of the zeros is complex, then we have another complex zero, and that complex zero is the conjugate of the given zero. So basically what this theorem is saying is, since 7i is one of the zeros, there is another complex zero, and that's the conjugate of 7i. Now, I don't know if you remember what a conjugate is through the PowerPoint that was posted in the semester one, but let me remind you, conjugate of a complex number. So for example, if I have a complex number a plus bi, then its conjugate is a minus bi. So just change the sign of the imaginary part. If it's plus, change it to minus. If it's minus, change it to plus. The real part remains unchanged. So example is, if I have 3 minus 4i, the conjugate of this is 3 plus 4i. If it's just 5i, the conjugate is negative 5i. If it's 3, it's a real only, it remains unchanged. Okay, so according to this theorem now, according to this particular theorem, so since 7i is one of the zeros, right, it means by the conjugate zeros theorem, which is right here in the blue, negative 7i is also a zero. So let's start the synthetic division one by one. I'm going to start with 7i first. So let's start with 7i. So I'm going to write 7i here, write the coefficients inside inside this division sign, which are 1. Remember, there is no x cube term, so I'm going to write a 0. And then I'm going to write a 40 for x squared. There is no x term, so I'm going to write a 0. And then negative 4 for 1. So the coefficient of x4, x cube, x square, x, and then a constant. If a term is missing, if a power of x is missing, you have to put a 0 for that. Otherwise, you won't get a right answer. So let's start with the synthetic division. 1 is carried as it is, 1 is copied as it is. Then you multiply 1 and 7i, you get a 7i. Add, you get a 7i. 0 plus 7i is just 7i. Then 7 times 7 is 14. I square is negative 1. So this becomes a negative 49, right? Add them, you get a negative 9. Negative 9 times 7 is 63, so you get a 63i. Add them, you get a 63i. In the next step, you multiply 63i with 7i, right? So 63 times 7 is 441, and so this must be a negative 63i, because negative 9 times 7 is negative 63. You add, you get a negative 63i. So basically you're multiplying a negative 63i with 7i. So negative 63 times 7 is negative 441, and then I square is negative 1. So it boils down to 441. When you take the product, it's 441. And you can perform this product in your in your calculator. There is a place for imaginary unit. If you go to either math or and if you search, there is an I in your calculators as well. So I get 441 and then I get a 0, so I'm good. I did my division correctly. Now for the second part, I'm going to divide, I'm going to continue and divide by now negative 7i. So once you are doing the second step, once you are doing the second synthetic division, you have to perform it on the quotient. On the quotient, you don't have to do it again in the original polynomial. When you reduce the degree means the quotient has the degree cube now, cubic degree. You will be performing synthetic division here. So I will continue like this. 1 is carried as it is, copied as it is. 1 times negative 7i is negative 7i. You add, you get a 0. 0 times anything is 0. So I'm going to write a 0 here. And then negative 9 when you add. 9 times 7 is 63. Both are negative, so plus and an I, so 63i, and I get a 0. So it means what I'm left is in the first step, I reduced it to a cubic from x fourth to x cube. My quotient was cubic. In the second step, I have reduced it to x square. So it means my quotient now, remainder is 0. My quotient now is x square. There is no x term, minus 9. And you have to factor it further. X squared minus 9, as you can uh, there are many ways to factor it, but if I use difference of two squares, one of the factors is x minus 3, the other one is x plus 3. So I have the so if I draw my chart about zeros and factors, if I draw my chart, so I have zeros and then I have factors, right? So 7i was already given to be a 0. I figured out negative 7i through my conjugate zeros theorem. Remember, it's only applicable with real coefficients. Real means the coefficients of these 40, 441 are real. It's applicable. If these coefficients are complex, this theorem is not applicable. But in this particular semester, we will be only dealing with real coefficients. So 7i minus 7i, and then you have from here, if I set this equals 0, I get x equals 3, right? And if I set this equals 0, I get x equals a negative 3. So one of the zeros is 3, the other one is negative 3. If I want to write this in factored form, this is x minus 7i, x plus 7i, x minus 3, and x plus 3. Okay, so if you remember, in the first part of semester, we did power 4 equations, which turned into quadratic. This is one of a kind of that equations. Now, this is a power 4 equation that turns into quadratic. So this turns into u squared plus 40u minus 441. This is my u, by the way. So then you have to factor this by figure out the value of u. So basically, if I want to graph this polynomial, this will, since it turns into a quadratic, it will have a u form. Two of them are imaginary zeros, so I cannot see them on the real plane, but the other two, 3 and negative 3, are your zeros, and they are linear. They are occurring only once. It's a symmetric function. It's an even function. I hope you know now what an even function is, what an odd function is. This is an even function because it has only even powers of x. Over here you can think of it as x to the 0. Even if you don't know this is an even function, that's fine, but it is like it's like a u-shaped function with x-intercept at negative 441, so somewhere here. So it crosses negative 3 linearly, it crosses 3 linearly, and it has a u form because it resembles a quadratic function. So that's how the graph of this function will look like. Okay, the graph is going to cross 3 and negative 3 only on the x-axis linearly like a line because they are occurring once. They are the zeros of multiplicity 1. They are the x-intercepts. And the y-intercept, if I set my x equals 0, it's negative 441, which is right down here. I mean, I cannot go any down further, but it's negative 441 here. And it's a symmetric function, so it's going to look like a u. So hope this makes sense, and let me know if you have any other question. Take care.